If you're looking for a troubleshooting guide on your Traefik configuration, especially when you're using the Gateway API, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the Kubernetes playlist where we cover a couple of episodes. A few months back, I introduced a series of episodes on how to observe your Nginx Ingress controller utilizing logs, metrics, and so on. In today's episode, I will focus on another proxy, and I'm referring to Traefik. For those who never heard about Traefik, it is actually the default proxy that you will get when using your Key3s clusters, meaning that it is a powerful proxy. Today's episode is going to be focused on explaining how we could troubleshoot Traefik in our Kubernetes cluster. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn from this episode. We'll start by presenting the Traefik project and, of course, how it works. Explain how we can configure Traefik in our Kubernetes cluster using the Gateway API. We'll cover, of course, the observability data provided by Traefik. And last, we will try to understand how we could troubleshoot Traefik using observability data and also the dashboard. Traefik is a powerful application proxy helping us to route, load balance, apply SSL or TLS to our Traefik. And of course, Traefik provides observability data in top of all those features. Proxy position themselves as a reverse proxy, easy to use by using the discovery mode, simplifying the journey. So it is positioned as a proxy that is simple to configure. Is it going to be the case in Kubernetes? Well, let's figure it out. When dealing with Traefik, it is important to understand the core concepts behind Traefik and how the Traefik is managed. That is crucial to start configuring it. Imagine Traefik as a traffic manager for your online world. Here are the various parts utilized by Traefik. So first you have the entry points. They are like the front door of our house. They listen to specific ports. You define which protocol will be actually utilized by Traefik. Then we have the actual routers. They figure out where the incoming request needs to go based on things like URL or HTTP headers and more. Services, they are the actual applications that will handle the requests. In the Kubernetes world, we could basically be pointing to our Kubernetes services. Providers, they are the technical components who tells Traefik about all the different services available. Traefik relies on providers to keep everything up to date. Traefik also uses this notion of middleware. Think of Traefik middleware as little helpers that sit between your users and your applications. When the user sends a request, the middleware can jump in and do things like modifying the requests, the response, add some security, redirect the user to another destination, a lot of different things. Essentially, middleware will customize how our Traefik flow through our system without changing the actual application. You can chain them together to create complex rules, and they operate on the HTTP protocol level. Here is a table summarizing the different types of middleware available. So you have the path modifier, notification, the request lifecycle, mist, content modifier, security, request, and more. But configuring specific details in a Kubernetes role sounds completely crazy. We don't want to touch configuration file of Traefik. We want to use CRDs. We want to be cloud native. So don't worry. Traefik supports, of course, Ingress and Gateway API. If you never heard about the Gateway API, check the following episode presenting the initiatives and the various CRDs provided by the Gateway API. If you're planning to get the experimental features of the Gateway API, make sure to deploy first the Gateway API first to have all the C headers available in the cluster and then install Traefik. Okay, so with the Gateway API, here is the deal with how Traefik handles the core stuff. So meaning the entry points, the routers, the middleware, and of course, the services. So let's start with the entry points. The entry points actually are the gateway resource that tells Traefik where to listen, which port, and which protocol. Traefik just set up its own entry points to match our rules. So every time I'm adding a new gateway, Traefik is supposed to adjust the entry points. Then you have the routers. Routers are basically the HTTP route, the gRPC, TCP route, TLS routes. They are basically the rules that defines based on the host names, the path, the headers, you name it. So Traefik takes these rules that we've defined in those routes, CRDs, and figure out how to send the traffic where it needs to go. So this is going to be the routers. Middleware, so where you can basically customize how things will go. So in the gateway API, you can use filters in the various route CRDs to do stuff like modifying the headers, redirect, and you can also consider applying, for example, timeout, rate limiting, and so on. So Traefik use those filters and we'll basically convert them into middleware so that to be aligned with the gateway API. And as we have these services, so the route resource tells basically Traefik which Kubernetes services will basically handle the traffic, and it's going to be using the reference of the gateway API called the backend specifications. Traefik makes sure everything gets to the right spot, respecting our configurations. Okay, so when we deploy Traefik we will probably going to use Helm. You will get several things within our cluster. So first we'll have a deployment to keep the Traefik pods that will act as our main proxy that will do most of the reverse proxy work. Then we have a services that will be deployed to make Traefik accessible outside. So you're going to use probably a load balancer services to have an external IP address. That will be also through that services, it will expose Prometheus metrics, and you can also expose the dashboards. So it's an option. So you will have to enable it in the Helm chart. You can also get extra things if you have enabled a few things about TLS settings. But Traefik will also deploy new CRDs to configure actually Traefik. Here are basically the main CRDs that Traefik will install. So you have the Ingress route, the middleware, the Traefik services, the TLS store, the TLS options, and the servers transport. But when dealing with the gateway API, we should not interact with those CRDs. I mean, maybe if you use TLS, but globally, if you do routing and everything and the filters in the routes, there's no need of touching those middleware components or even ingress routes, because at the end, it should basically detect them through the providers and then manage this directly in Traefik. When deploying Traefik with the Kubernetes Gateway API enabled, then Traefik will deploy by default a gateway API in the Traefik namespace. This gateway will expose two sets of listeners, so web 8080 meaning 80 from the Ingress perspective, and then we have the similar for the web secure, I would say, it's 8443, meaning it's basically SSL 443 also for the Ingress perspective. So if you're planning to expose more ports from your gateway API, you will need to define more endpoints in Traefik. To achieve this, you will need to modify the deployments of Traefik by adding your new endpoints, for example, to expose, in our case, let's say the OpenTelemetry ports. So we can have the entry points for the gRPC for 317 and the one for OTL HTTP for 318. So, or you can also do this directly when deploying Traefik with Helm by modifying the value file of Helm by adding as many entry points as you want in the default gateway. Then once those entry points exist, I can create my own custom gateway API, making the reference to the two endpoints name that we've just created. So in this case, gRPC and OTel HTTP. Otherwise, for simple routing, you can configure your route using simply the gRPC or HTTP route CRDs if you simply want to apply on the default web secure and web entry points that are by default created. When applying your various gateway API CRDs, you can check in the dashboards provided by Traefik to check if they have been properly managed by Traefik. But we will look at this later in the troubleshooting section. Anyway, so the dashboard is exposed on the port 8080. So if you configure non-secure, but you can simply do a port forward on the Traefik pod. So here, for example, I'm doing kubectl port forward on the Traefik part, which is in the namespace of Traefik. And then I can just simply open my browser, go to localhost 8080, and then here we go, we get a dashboard, and we can look at the entry points, the router, the services that are currently managed by Traefik. So here I have configured the gateway API to have TLS enable, and here we can see that there's a SSL route to the OpenTelemetry demo. Out of the dashboard, Traefik, like any proxy, will expose data in various ways. So it exposes metrics collected at the proxy level. It exposes its own logs, the log produced from the activities on the proxy through the access log. And last, it is able to also produce traces. As you may expect, the Traefik project followed the industry by providing an OpenTelemetry support. But what that is actually means? Well, Traefik will produce OpenTelemetry metrics, but of course, you will need to enable it. The same metrics could also be exposed using Prometheus, meaning that Traefik will become a Prometheus exporter. OpenTelemetry traces, where each individual request managed by Traefik will produce some spans. The trace produced will share details about all the various components of Traefik involved in the process served by Traefik. So the router, the entry points, the middleware, and so on. And last, it also exposes logs by enabling the experimental feature on logs to get the OpenTelemetry support. But when preparing this episode, I played around with various settings. For me, there are a few things to consider. So first, metrics. Using OpenTelemetry won't change the metric produced. It will only emit the metrics using, of course, the OTLP protocol or OTLP HTTP or gRPC. So the metric structure is the same as Prometheus, so we can completely replace it by exporting it with the OTL exporter. On the traces, it makes sense to include to our end-to-end traces the details provided by Traefik. And in this regard, I clearly recommend to add the options add internals, to add all the steps, including the work done by the router, the middleware, or other components. One important thing is that Traefik will be by default producing 100% of sampling decisions. So make sure to configure the sampling rates, or if not, use the OpenTree collector that will be responsible of doing the sampling decisions before sending it to your backend. This is what I've done in the tutorial by using, of course, a collector doing tail sampling. Last, we have logs. So I was expecting to get all the type of logs of Traefik to be pushed using OpenTelemetry. Maybe I did something wrong, but I was not able to collect the Traefik access logs using the OpenTelemetry protocol. When enabling the OTL export for logs, I actually get the logs from the Traefik engine, highlighting the route used, the potential issues related to our configurations. So at the end, very interesting detail. On the access log, it seems to be only exposed in stdout of Traefik. So for this, I would use either Flinbit or the collector deployed as the daemon set. Then to simplify the processing of our logs, I can configure the log format in JSON format. So I would recommend to do that. So let's look at the actual configurations. In the value file used to deploy Traefik, I should configure the tracing, the metrics, and the log sections. So for example, here you can see that I have the tracing sections. I'm adding all the different sampling rates. I want to add the add internal, configure the actual exporters, so I get all the different details. In these settings for the traces, you can ask Traefik to extract HTTP header and add them as span attributes produced by Traefik. So that is an interesting feature, especially if you have some HTTP headers that make sense to be added in the span. On the metric side, it would be quite similar, so nothing differences. On the log side, it would be a bit different. So first, you need to enable the experimental feature. So here it is in the experimental section, you will have to do OTLP logs equal true. And then you can add the OTLP sections in the log sections of your value files. Otherwise, you can pass the parameters to your deployments of Traefik. So here it is, you can pass a lot of different details for the log configurations, for the tracing, for the metrics, and so on and so forth. Traefik provides a dashboard that acts as a crucial visual interface for understanding and debugging your Traefik proxy configuration. So let's have a look at the Traefik dashboards where to look when things are actually going wrong. So in the entry point section, this is where you'll see all the entry points you have set up, what ports they're using, and if there is any TLS setting. So if something goes wrong with the entry points, for example, your server is not listening, if you don't see the entry points or it says not listening, double check if you're setting up properly. Make sure they have actually any port conflicts that you have been created with the entry point. If you're applying Gateway API, CRD, and you don't see the entry points, maybe you should first create the entry points in Traefik and then create your Gateway API. Maybe have a wrong port. Make sure that the port that listens are the ones you have actually defined or to use. Otherwise, Traefik might not get where it should. The TLS problems for entry points with TLS, check that they have a valid certificate, that it's not missing or expired. You will probably see an error, so check the TLS settings and certificate results. So routers. In the routers section, this is where the place to go if you have basically a routing issue. It shows all the active routers, their rules, the services they are connected to, and any potential middleware. So weird rules interpretation. So make sure that, for example, Traefik is actually understanding your rules correctly, especially if you're using the Gateway API resources. Check if the host names and the path matcher in your HTTP route look right in Traefik rule format. If wrong service, make sure that the router is actually pointing to the service that you want to send the traffic. Last, middleware issues. Check out the middleware applied to the router are actually working and moreover supported by Traefik, because you can maybe use some filters available on TCP route, but they are not working in Traefik. Basically, just starting at the Traefik dashboard is like waiting for things to break before fixing them. I mean, it's great to use a dashboard, at least when you're configuring things, but in a real-time production system, it doesn't make sense. So you can get ahead of problems by, of course, looking at the Traefik logs. These logs are gold mines for setting up alerts. So the error log tells us what went wrong, like bad filters in the HTTP routes. You'll find the specifics in the log body. It makes it easy to spot potential issues early on. It provides also various fields that we could rely on to create alerting rules. So the first one is, of course, error, sharing the reasons of the actual error, like unsupported filter in the case of HTTP route. For the HTTP proxy problems, I will recommend to look at the access log. It's gonna be our best friend. It'll share lots of details, how long the proxy took, so it includes the extra time needed, and this is basically the field called overhead. So look at these fields to measure the time spent in Traefik. Status code, because you have an origin status and a downstream status. So if they don't line up, something probably is wrong in our routing or middleware rules. Network issues. For this, it's great because the access log has a message field that will share details on network issues. So it's great to be able to identify rate limiting situations or timeout or other things. Metrics are also very helpful. For instance, Traefik entry points request total, breaking down by the status, the entry points, the HTTP methods can point out unusual failing requests and where they're coming from. You can do the same metrics, in fact, for the router. So they have the similar metric for the router. And of course, they have a similar one for the service level. Traces aren't directly for troubleshooting right now, but the access log has the trace ID and the span ID. So connecting the dots between logs and spans will be very helpful to understand the entire problems within the actual request. To be proactive, I would say use logs and metrics to catch Traefik issues early. The error log gives you the specifics. The access log has all the details about any URL or any proxy activities, and metrics provide a high-level view of request handling. That's it for today's episode related to Traefik. I mean, Traefik is an amazing proxy or reverse proxy in bare metal environments, but also in Kubernetes. The fact that it supports the Gateway API CRDs make our configuration much more easier because we don't have to go to the specific details configuration from the configuration aspects of Traefik. I was expecting the gateway providers to basically take my Gateway API CRDs with my listeners and then create those entry points and for the reason it never happened. So maybe it's an issue on the current version of Traefik that I'm using, but yeah, for me, I had to modify the entry points, apply the CRDs, and then it worked. One small note, it's gonna be an ingress, so similar to NGINX. So if you try to use HTTP route or gRPC route that applies filters more specific on the service mesh level, it may not work completely. So I tried, for example, request mirroring, it didn't work. So yeah, few things should be tried out before applying the standards that the Gateway API provides currently with the experimental layer provided by the Gateway API. On the observability stuff, I was a bit surprised that I didn't get the access log from on the OpenTelemetry perspective, but not a big deal. I'm used to collect anyway the logs from the cluster using a daemon set agent. In my case, it was the collector. And because it's on a JSON format, very simple to parse, so not a big deal. But still, I was surprised to only have the Traefik access logs and not the overall logs in general. So on the metric side, no problem. On the traces, no problem. But yeah, from the logs, yeah, maybe it's a current issue. It will be resolved in the future. But yeah, you will have to collect those different details on different way. And to be honest, for me, it was easier because at the end, having a source that has no log file, because at the end, if it's OpenTelemetry format, there is no log file in the metadata, it was easier for parsing. So then I know that if that log was coming from Traefik, I know it's the engine, so I will deal the log in a specific way, and then I had another rule for the actual logs coming from the access logs. So maybe a small issue at the moment, but at the end, maybe for me it was an advantage to simplify the actual processing of the logs. Anyway, if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.